Hi, my name is Justine Harkness, and in this video, we'll look at how to synthesize an alcohol using an alkyl halide substrate. We can make alcohols from alkyl halides using nucleophilic substitution reactions. And depending on the type of alcohol we want to produce, we can do this either through an SN1 or an SN2 pathway. Now, if we're interested in making either a methyl or a primary alcohol, we'll be starting with either methyl or primary alkyl halides, which undergo SN2 reactions. Because an SN2 reaction requires a strong nucleophile, we use hydroxide as the nucleophile. But if we're instead interested in making either a secondary or a tertiary alcohol, we would need to start with a secondary or tertiary alkyl halide. These types of alkyl halides prefer to undergo SN1 reactions, which can use a weaker nucleophile, so we use water as the nucleophile. If you need a little refresher on SN2 and SN1 reactions, go back and watch some of the earlier videos. But let's take a look at how we can apply this to some synthesis reactions. Now, in these questions, we'll have parts A through C. We need to produce these following alcohols, and we need to choose an alkyl halide substrate. We need to choose a nucleophile, and we need to choose a solvent, and also draw the mechanism for this synthesis. Now let's take a look at the alcohol that we want to produce in A. This here is a primary alcohol. So to do this reaction, we would need to start with a primary alkyl halide, and we'll essentially replace this OH group with some sort of halogen. Here we use chlorine. You can really use any of the halogens except for fluorine, because remember, fluorine is not a good leaving group. Now, primary alkyl halides will undergo SN2 reactions. So as we draw out our synthesis, we need to use a strong nucleophile, which would be hydroxide, and we would need to use some sort of polar aprotic solvent, something like either acetone, we can use DMSO, we can use THF, really anything that is polar aprotic. Now for the mechanism, our hydroxide is going to come in and attack and kick off the leaving group all in one step to give us our final alcohol. So this would be our choice of substrate, nucleophile, solvent, and our mechanism. Now let's take a look at a secondary alcohol. So this here would be a secondary alcohol. And to choose our substrate, again, we would just replace that OH group with a halogen. Here we've chosen to use chlorine. And secondary alkyl halides will prefer to use an SN1 pathway. So the first thing that will happen in this reaction is that our leaving group will leave. And we would use some sort of a polar protic solvent for this, and we can do this actually just in water. So once our leaving group has left, we now have a secondary carbocation. Remember, this is an excellent electrophile. So we can have water, which will function as both our nucleophile and our solvent. It will come in and it will add to that carbocation. Finally, we have water added, but notice it has a positive charge. In order to get to just the alcohol, which is neutral, we would need to lose a proton. So the final step in this mechanism would be a deprotonation, so just minus a H+, and it could be taken up by one of the solvent molecules. And then we'd have our final alcohol. So here we use water as both the solvent and the nucleophile, and we had our substrate, alkyl halide, just with the chlorine in place of the alcohol. Finally, let's look at part C. Now here we have a methyl alcohol, So to produce this methyl alcohol, we'll have to start with a methyl alkyl halide. Again, we've put chlorine in place of that OH group, but you could probably use bromine or iodine as well. Now, because we have a methyl substrate, this will undergo an SN2 reaction. So to choose our nucleophile, we would need to use a very strong nucleophile. We would use hydroxide, and we would do this reaction in a polar aprotic solvent, something like DMSO. Now, for our reaction mechanism, we'll have OH minus come in and attack the backside and kick off our leaving group. And this would give us our final alcohol. So now you should feel more comfortable drawing a synthesis reaction making alcohols from alkyl halides.